Hi guys, this is our last video for trigonometry, and in this one we're going to go through the tangent graphs. So you should have gone through sine and cosine graphs, and from that there's nothing really new in the tan graphs, they just look a bit different. So the tan graphs are made up of two things. They're made up of the period, similar to sine and cosine, and they're also made up of an asymptote. Now in this case, a period starts at the origin, splits over the asymptote, and ends up there. Okay, so we're actually kind of splitting it. So we start, this is a positive one, obviously it's going up, stop at the asymptote, down and back up. So the period for tangent looks quite different than that of sine. Okay, we find it in much the same way. We find, we have a formula there and we find the period. So in this case, the period is pi, and then we go from there. The other part that makes this up, which is a bit new to us, is the asymptote. Okay? The asymptote falls every half a period, which, if you remember back to logs and exponentials, an asymptote is a limit. It's a line that the graph goes very close to, but it never actually hits and it never crosses. So in this case, there's an asymptote every period, and it occurs right in the middle of the period. So we're going to find the period, and then a bit of a cheat sheet for you. The asymptote is just half of whatever the period is. Okay, you just half whatever it is. So in this case, it's pi. Half of pi is pi on 2. So with that in mind, those two things, period and asymptote, we're going to do a couple of the examples. But first, I'm going to take you through a bit more extended version. This here is from your formula sheet. You can see down here, let me do different color. They use y equals tan of nx. I am going to show you one with a and b in it as well. For your knowledge, also some of the exercises, we do take it into account, and I think it helps your understanding as well. But it's a bit of a tip off that the formula sheet just has an n there. It doesn't have an a or a b. So just keep that in mind as we go along in regards as to what you might be assessed on. Yeah, bit of a hint there. Again, we don't know what's going to be on the exam, but keep that in mind with the formula sheet. So we're going to look at the full hoist. So let me draw a bit of a tan graph here. I've got my axes. I'm going to put my asymptotes in. And I'm going to draw two periods of a tan graph. So my first period goes to there, and my second period goes to there. All right, so n tells us a bit about the period and therefore the asymptotes. So n has the ability to move these periods left and right to make them steeper or to make them less steep. Words are escaping me. We're also going to look at a. So what a does is a tells you a point on the graph halfway here. So halfway between your starting point and your asymptote. So if we look at, let's say that this period was 2 pi, my asymptote would be half of that, which is just pi. And then if we half that again, a tells us what the value is at pi on 2, which in this case, it's 1. Okay, so if we had, say, a 3 here, 3 tan of nx, at pi on 2, this would be a lot steeper. And at pi on 2, it would be 3. Okay, so that kind of tilts it and it makes it a bit steeper. It doesn't make it closer together. It will still go over to the asymptote. It will just take longer to get there because it's a bit pointier. The other one we can look at is B. B moves the average. So remember in sine and cosine how we went off the average, we went up and down from the average? It's no different here. So if we had, say, +3 here, it would move our average up and our graphs would go from there. Okay, it would move our entire line up. So just keep A and B in mind. There are a couple of exercises in an exercise sheet, but as I said, it's not part of your formula sheet, which could mean something. We shall see. So you're probably wondering how we're going to find the period and how we're going to find the asymptote. As I said, asymptote's half of period, but we do need to be able to find the period. So down here, we've got n from our formula, and we're just going to divide pi by n. So let's have a look at what that looks like. So I've got my formula sheet over on the side here just so you can see what I'm talking about. And we want to find what n is. In this case, it's 2. So the period is going to be pi on 2. Okay, pretty simple. The asymptote is half of that. So you can do a couple of ways. You can go pi on 2 times a half, which gives you pi on 4. You can go pi on 2 divided by 2, which cross multiply pi on 4. Or you can use their little formula here, which is a bit kind of the long way around, but if you forget that it's a half, then that's all you've got. So it's n of x equals pi on 2. We know that n is 2, so 2x equals pi on 2. We're going to divide both sides by 2, and we end up with pi on 4. So the easiest way is just to double the denominator straight up. It'll make life a lot easier, but if you forget, it is kind of a roundabout way on the formula sheet. So in this case, pi on 4. So if I wanted to graph that then, we might do the first 2 periods. So here is pi on 2 halfway, that's 1 period. And I'm going to go to pi. Okay, I'm only going to mark the first one, but just to show you what it would look like. So my asymptote goes down the middle, that's pi on 4. And I've got another one here, which is pi on 2 plus pi on 4. Okay, I need to make same denominators, so this becomes 2 pi, which is 3 pi on 4. I'm going to write that. Okay, or you can think 1/4, 2/4, 3/4, whichever works for you. Hopefully your fractions are getting a bit more comfortable at this stage. So what I need to do is start from the origin. That's my dog going off because my other dog just stole its bone, sorry. So we're going up here, up there, and up there. You should probably mark your other point in, which I'm about to do first, but we all know we kind of draw the shape first. So at halfway through, which is pi on 8, my bit there is going to be 1. Okay, not so important when there's just a 1 out the front, but if you see a number there, make sure you mark that point in. Okay, so pretty simple. Period is found by pi over n, and the asymptote is half of that. So let's try it with the same theory, but a bit more difficult question. This one's a bit more difficult. We can see, I'm going to have to put him outside. Let's try this again. Okay, so we've got a fraction there, which makes it more difficult. We've got a number at the front, and we've got a restricted domain. So they want us to draw it from 0 to 2 pi. So we're going to start by finding the period, and then we're going to half it to find the asymptote. So the period is pi divided by n, except in this case, n is a half. Okay, so a little bit of fraction work. We turn them both into fractions. We flip the second one, and we multiply them. So this gives us 2 pi. So our period is 2 pi. That makes it pretty easy for us to find our asymptote. Half of 2 pi is 1 pi. So our asymptote is just pi. So they're the two main things we need to be able to graph it. So we're going to draw our axes. We're going to go to 2 pi, which is 1 period, which means the asymptote is going to be straight down the middle. and that is going to occur at pi. Now halfway between that, which is pi on 2, we're going to have a point at pi on 2, 3 because of this number out the front. So we're going to go up this way and along this way. It's a bit dodgy. Okay, so that is one cycle of 3 tan of x on 2. So we're just finding the period, halving that to find the asymptote, and then graphing. You might see some that even have their domain restricted, say maybe 3 pi. There's one in your exercises like this. So you're just going to kind of cut your domain off there, and you're just going to have it not the full cycle. So just be careful of those ones. So in conclusion, very, very similar to sine and cosine, bit of a different shape, but we still have the period there, which is given on the formula sheet, and we have an asymptote in this case. So have fun with the exercises. Sorry again about my dog.